Hey everybody, let's talk about how we calculate unsaturation number and then what we're going to do with it. Let's start by defining what a degree of unsaturation is, and that's how we're going to calculate our unsaturation number. A degree of unsaturation in an organic molecule is a pi bond. So we've talked about those being present in double and triple bonds, as well as a ring. Each of those, each individual pi bond and each ring is a degree of unsaturation. And the total number of those features will give us our unsaturation number. So as I take a look at the 5 structures that I've drawn down below, we are looking for pi bonds. So we're looking for double and triple bonds. This molecule on the left has 1 pi bond right there in that double bond. Remember, the first bond is a sigma, the second is a pi. And so this one will have 1 degree of unsaturation, or an unsaturation number of 1. The ring next to it, there's a ring and a pi bond. So you get 1 degree of unsaturation for the ring and 1 for the pi bond. That's a total of 2. Over on the right, we have a triple bond. Remember, a triple bond has 2 different pi bonds in it. And so my unsaturation number for that molecule is 2. For the benzene ring, this one's the heavy hitter. It has a ring and 3 pi bonds. This has a total unsaturation number of 4. The last structure I have drawn will have an unsaturation number of 3. There are 3 distinct pi bonds in this molecule, and so that is its degree of unsaturation. Looking at a structure, we can determine its unsaturation number. You can also figure out the unsaturation number for a molecule from its molecular formula. And there's a way to do this. You take the molecular formula, so A number of carbons, B number of hydrogens, C oxygens, D nitrogens, and X halogens, and you plug it into the formula down below. You'll be given the formula, don't memorize it. You're going to take 2 times the number of carbons, add 2 to that. You're going to subtract the number of hydrogens, subtract the number of halogens, add the number of nitrogens, divide by 2. You'll notice we don't have to do anything with the number of oxygens. The presence of oxygen does not change the unsaturation number. Let's apply this formula to the 3 examples down below. For this first one, my unsaturation number will be 6 times 2 plus 2, minus 12 for the hydrogens, divided by 2. This is 1. This molecule will have 6 carbons, 12 hydrogens, and either 1 pi bond or 1 ring. The second molecule here, C6H12Cln, again, 6 times 2 plus 2, minus the hydrogens, minus the chlorine, plus the nitrogens. We're back to another unsaturation number of 1. There'll be 1 pi bond or 1 ring in this structure. The molecule on the right, that formula, your unsaturation number is going to be 3 times 2 plus 2, minus 4, divided by 2. Again, oxygens don't impact your unsaturation number. This has an unsaturation number of 2. So at this time, you should be able to look at a structure, determine how many degrees of unsaturation there are, or what its unsaturation number is. You should be able to calculate that unsaturation number from a molecular formula. What are we going to do with this? The purpose of an unsaturation number that we are going to put it to is what's going to help us draw potential structures for our molecules. You are going to be given, as we continue in this unit, spectra and a molecular formula. And you're going to be asked to tell me, what is this molecule? Well, you need to be able to draw some possibilities to start figuring out what makes sense. And so the first thing you'll do in these situations is you'll calculate the unsaturation number. So let's take a look at this molecule, C5H10O. The unsaturation number for this molecule is 1. So in this molecule, there are 5 carbons, 10 hydrogens, 1 oxygen, and either a pi bond or a ring. So your task is going to be to draw different types of candidate structures, so different molecules that fit these parameters. The simplest possibility, perhaps, might be all 5 carbons in a row, your alcohol hanging off, and a double bond somewhere. And you could put that double bond in a couple of different places. We don't have information just from our molecular formula about where it needs to go. But I want you not just to limit yourself to a single functional group or just to straight chain molecules. You could take this same idea and you can change where the alcohol attaches. You can have it branch as long as you still include 1 degree of unsaturation. What if you have a ring? You could have a 5-membered carbon ring with an alcohol on it. Or heck, let's go something totally different. Let's make it a ketone. That takes care of our degree of unsaturation. No one said it had to be a carbon-carbon double bond. You could make something an aldehyde, and you could even make it a branched aldehyde. Just check to make sure you've got the right number of carbons. You can make it an ether. Again, just check to make sure that you've got the right number of carbons. Happily, if you're using your unsaturation number appropriately, so you know that you have the appropriate number of pi bonds or of rings, the nice thing is the number of hydrogens will work out. So if you count your carbons and you have any other elements that you need, the hydrogens will automatically be there. And so you don't have to go back and count every single hydrogen as long as you're using your unsaturation number. But as you start drawing these candidates, the key as we move forward in spectroscopy is to draw lots of different types, have different branching patterns, put double bonds in different places, try rings, try aldehydes, try ketones, try a variety of different functional groups so that you have some variety to start working with. Then you can use the spectra to narrow, to funnel, to guide, to see if any of your current pictures work, and if none of them work, to figure out which ones are closest and how you might adapt them to get towards a correct, reasonable structure that matches all of the data information. We are certainly going to be doing plenty of practice in class, but bring in questions about what unsaturation number is and what we're going to do with it and how we're going to use it.